Hopefully you're starting to get the hang of how these charts work. I want to do two more examples here to illustrate something that comes up in coin problems and something that comes up with profit problems. So, here's the problem. A collection of 52 dimes and nickels is worth $4.50. How many nickels are there? Well, of course, what we don't know are nickels and dimes. And just as we've been doing, if I know how many there are, and I know how much each one is worth, then I can figure out the total amount of money there is. The problem asks for how many nickels there are, so we're going to have nickels be represented by X. The other thing that's here that you really need to get used to is that all we know about the number of coins is that the collection is 52. In other words, the total number of coins is 52. As soon as I see that, I know I can have one of my variables, one of my quantities be represented by the variable, and the other one is represented by the total minus X. In other words, if X is the number of coins, then the rest would be the total minus how many nickels there are. You really need to wrap your brain around that and get so that you can do it fairly easily. Every nickel is worth 5 cents, so I'm going to call that 5, and every dime is worth 10 cents. So I don't know how many nickels I have, but I know that the total amount is 5 cents per nickel, so 5x. Similarly, this is going to be 10 times 52 minus x. The other fact in the problem is that the collection is worth $4.50. Notice here, we're talking about 5 cents and 10 cents. So when I add this together to get my equation, because of that's what it's worth, 5x plus 10 times 52 minus x, I need to call it 450, not 4.50. 4.50 would be in terms of dollars, $4.05. So since I'm calling this in cents, I need to also think of this in cents. I really don't think that we need to go through the algebra of solving this equation. I will tell you that when you solve it, you find out that x is equal to 14. When I look back at my chart, I can see that I said that x was going to represent the number of nickels, and that's 14. And in fact, since the problem only asks how many nickels there are, we've solved the problem. It's 14 nickels. Okay, the next kind of problem has to do with profit. As we talked about in class today, if a certain young entrepreneur wants to go into the pencil selling business and they buy 100 pencils at 10 cents each, 10 cents each, this time I'm representing it in dollars, then I know that 100 times 10, and this is a quick review, I know you know this, but in powers of 10, if you move the decimal point over as many places as there are zeros. So that means that this is going to move over 2, and that means that the person is putting out $10 when they are buying their product. If they sell those same 100 pencils for 20 cents a piece, that means that they'll be bringing in $20. In this situation, it's quite simple to see that the profit is is $10. Because if I take 20 that I bring in and I subtract the $10 that I had to put out, that gives me 10. In other words, though, this is the part that you will sometimes forget when you're in the middle of a chart problem. You need to take sold and subtract bought to get the profit. With that in mind, let's do a problem. This is actually in your homework tonight. It's about a girl who's buying 12 apples, eating 2 of them, and selling the rest at 20 cents more per apple than she paid. Her total profit was $1. So we've got bought and sold, and as we're hopefully getting used to, if you know the number times the price per, you can figure out the total. So we need to figure out which of these boxes we can fill in right away. What we know is that she bought 12 apples. That means that in this column we're going to have constants. We bought 12 apples. She bought 12 apples. She sold all but 2, which means, or she ate 2 of them, meaning that she sold the rest. That means there were 10. She sold the rest at 20 cents more per apple than she paid. The last one mentioned when compared is paid, so that will be X. Again, that doesn't always work, but around over 90% of the time, it's the easiest way to follow the language. She sold the rest at 20 cents more, so 20 cents more than how she bought them is X plus 20. So now we've got 12X. And we've got 10 times X plus 20. Now we have to see, does our common sense remain in place? I'm going to give you the words again. We found out that sold minus bought gives the profit. So we don't know the amount of money that she got when she sold, but we are having a variable expression for it. 10 times X plus 20. That represents the sold money. From that, we have to subtract what she put out in money when she bought the apples, and then we talk about the profit. Once again, since I am calling this in terms of cents, that's 20 cents, not $20, I have to express the profit of $1 in terms of cents. It needs to be 100. And I will leave you to solve that equation. Just remember, when you find X, you will have found what she bought them for. The problem asks what she sold them for. So make sure you go and back and answer the question that's given.